Okay, so how many of do you believe that this subject will be useful to you in future? Am I audible to everyone?
Yes, sir.
So do you find that this subject will be useful in your future as computer science IT engineer?
Yes, sir.
Yes, sir.
Or is it just a subject which you are reading just because it is there in the syllabus and you have to pass the exams? That is why you are reading this subject. Because every year in one class we have 150 students, and out of those 150 students, uh, 10 to 20% are usually interested in becoming engineers genuinely. Just everyone else is like, "Ki we should clear the exam and then we should get the degree, and after that we will see once we become engineers." So currently, this is the attitude in the entire country for students, engineering students. They believe that if they get degree, they will get job, but that's not true. And even if you manage to crack some beginner level interviews and get into companies, your progress profile will be significantly lower if you do not understand your subjects well. And at that time, people shift to the managerial side in various companies, which is very difficult at later stages of career. So every subject that you are using in CSIT, it will be used somewhere in your profession later. So ये लैब्स जो है आपकी 2:45 से हर जगह स्टार्ट हो जाती है या फिर सब 3 बजे तक ही आते हैं ऐसे ही?
सर 2:45 पे तो हमारी क्लास ही छूटती है।
2:45 तक क्लास छूटती है? नहीं, आपका टाइम टेबल जो मेरे पास है उसके अकॉर्डिंग तो शायद आप लोगों की क्लास 2:30 तक छूट जाती है।
सर थोड़ा एक्सटेंड हो जाती है ना, वो 5-10 मिनट सर एक्सटेंड हो जाती है कभी कभी।
10 मिनट एक्सटेंड, अच्छा, मतलब कुछ एक्स्ट्रा कंटेंट कभी बच जाता होगा तो वैसे आप कह रहे हो। बाकी जो आपकी ऑफिशियल टाइमिंग्स हैं दैट आर टिल 2:30। जैसे ये शायद आपका 5th सेमेस्टर का टाइम टेबल है फॉर ECE, फॉर this is for EC, this is for CSE branch. So yeah, 2:30 पे आपकी क्लास एंड हो जाती है and 2:45 to 5 PM this lab is there. So बाकी labs भी आप लोग 3 बजे ही स्टार्ट करते होंगे फिर?
ये सर सब 3 बजे ही स्टार्ट होती है।
But official timings are from 2:45. That is why I schedule it from 2:45. But actually Microsoft के सॉफ्टवेयर में थोड़ा सा ग्लिच है, वो 2:45 से शेड्यूल नहीं करने देता कुछ भी। So अगर आप उसमें PM डालते हैं तो वो AM बन जाता है सिर्फ 2:45 के लिए, बाकी सारे टाइम्स वैलिड है. So I had to schedule it from 2:30 only. But anyway, let's see when people join, we will begin. So कोविड की टाइम में तुम लोग घर पे पढ़ाई तो करते नहीं होगे, लेक्चर भी तुम लोग बस लॉग इन करके पता नहीं कहाँ सोते रहते हो. सीरियसली कितने लोग पढ़ाई कोडिंग वगैरह करते हैं घर में? अच्छा, कोडिंग वगैरह कितने लोग सीरियसली करते हैं, जरा हाथ उठाओ. Few people. 10 out of 28, 1/3 approximately. कौन सी कोडिंग ज्यादा पसंद है आपको? C, C++, जावा, पाइथन, C#? .NET,
C++.
C++। अच्छा, उसमें क्या पढ़ते हो? डेटा स्ट्रक्चर्स एंड एल्गोरिथम्स?
Yes, sir.
Yes, sir.
क्योंकि वो जॉब के लिए जरूरी है इसलिए।
Yes, sir.
C++ में फ्रेंड फंक्शंस पढ़े आपने?
Yes,
Yes,
sir.
sir.
क्या होते हैं फ्रेंड फंक्शंस?
Sir, friend function is used to access the private and protected function of any class.
तो उनको फ्रेंड क्यों बोलते
If the
हैं?
function,
सर क्योंकि वो नॉन मेंबर
Sorry, sir?
फंक्शन होता है, क्लास का मेंबर नहीं होता, बट स्टिल इट कैन एक्सेस द प्राइवेट मेंबर्स ऑफ दैट क्लास।
अच्छा, अच्छा, जो बड़ी प्रोग्रामिंग लैंग्वेजेस होती हैं जैसे मैटलैब, पाइथन वगैरह, जिसमें ये इमेज प्रोसेसिंग, वीडियो ऑडियो प्रोसेसिंग सिखाते हैं, दे डू नॉट हैव पॉइंटर्स एंड ये सारी चीज़ें। तो पॉइंटर्स ना होने की वजह से कोई दिक्कत नहीं होती? मैटलैब, पाइथन, इन सब में पॉइंटर्स हैं ही नहीं। और लिंक लिस्ट बनाने के लिए तो पॉइंटर चाहिए ही चाहिए। ट्री का एफिशिएंट इम्प्लीमेंटेशन बनाने के लिए तो यू विल नीड पॉइंटर्स। सो हाउ डू यू डू विदाउट दैट इन दीज लैंग्वेजेस? मैटलैब में यदि पॉइंटर बनाना हो या पाइथन में यदि पॉइंटर बनाना हो, सो हाउ डू वी डू दैट? अच्छा, पाइथन कितने लोग जानते हैं? Raise your hands if you also practice Python or MATLAB.
only some basic.
Basics of what? MATLAB or Python?
Both.
अच्छा, तो वो खुद से पढ़ा या किसी कोर्स में आता है आप लोगों को?
कोर्स में।
अच्छा, कोर्स में। ओके। हाँ, शायद आपके सिलेबस में मैंने देखा था, इमेज प्रोसेसिंग का कोर्स है ना इस बार?
Yes, sir.
काफी इंटरेस्टिंग होता है वैसे इमेज प्रोसेसिंग। बनाए कुछ उसमें आप लोगों ने प्रोग्राम्स वगैरह इमेजेस को उनसे डील करने के?
Yes, sir.
क्या क्या बनाया?
Arithmetic operations, image equalizer, histogram
इक्वलाइजर
equalizer.
मतलब हिस्टोग्राम वाला इक्वलाइजेशन?
Yes, sir. Yes, sir.
अच्छा,
सर हिस्टोग्राम वाला।
हिस्टोग्राम बनाया, और क्या बनाया?
The conversion of image into grayscale.
वो तो एवरेजिंग से हो जाता है या आरजीबी टू ग्रे फंक्शन से भी हो जाता है?
Yes, sir.
अच्छा, तो अभी वहीं तक पहुंचे होगे कोर्स में, मतलब धीरे धीरे करके चल रहा होगा कोर्स, तो वहां तक पहुंचे होगे अभी?
Yes, sir.
ओके, अच्छा, चलो 2-3 मिनट और वेट करते हैं, फिर स्टार्ट करते हैं, क्योंकि अभी भी केवल अराउंड 38 बच्चे हैं सिर्फ। बाकी और कोडिंग की लैब्स कैसे होती हैं तुम्हारे यहाँ पर? मतलब जैसे और भी जो तुम्हारे कोडिंग के सब्जेक्ट्स होंगे, सो लैब्स में कैसे, मतलब और टीचर्स कैसे कंडक्ट करते हैं लैब्स?
सर क्वेश्चन देते हैं और उसको नेक्स्ट लैब में सबमिट करना होता है।
अच्छा, सबमिशन भी होता
और कुछ
होगा।
मतलब
ओके।
जो बेसिक्स होते हैं वो थ्योरी समझाते भी हैं, मतलब स्टार्टिंग में सारा थ्योरी समझा के उसके बाद क्वेश्चंस वगैरह दे के सबमिट करना होता है।
तो सारी लैब्स फुल 5 बजे तक होती है, तुम लोग बीच में भाग जाते हो?
ना सर 5 बजे तक नहीं होती वो, मतलब जब असाइनमेंट मिल जाता है मतलब क्वेश्चंस वगैरह, उसके बाद ऑप्शनल रहता है। अगर प्रॉब्लम है तो मैम मतलब टीचर्स वहाँ रहते हैं और जिसको प्रॉब्लम होता है वो पूछता है, या फिर मतलब अटेंडेंस तभी हो जाती है, उसके बाद लीव भी कर सकते हैं, ऐसा रहता है।
हाँ, वो तो सही बात है, बट लीव जैसे अटेंडेंस तो किसी भी टाइम पे लो, इस सॉफ्टवेयर में लॉग इन लॉग आउट टाइम आ जाता है ना, तो कौन यहाँ पर 2 मिनट के लिए बैठता है, कौन यहाँ पर पूरा 1 घंटा बैठता है, वो पता लग जाता है। सो अटेंडेंस तो यदि शुरू में हो या एंड हो, वो पूरा लॉग इन लॉग आउट टाइम आ जाएगा, मतलब जहाँ तक अटेंडेंस ली है वहाँ तक का टाइम आ जाता है। मैसेज डाल देता हूँ व्हाट्सएप ग्रुप पे, तुम लोग पता नहीं कहाँ सोते रहते हो, लोग ज्वाइन ही नहीं कर रहे हैं लैब। Okay, so let us start today's lab. Let me start recording also. और कुछ there are some interesting programs that we look to make today. Because now since we have started with interfacing, so there are various elements which we would like to interface to our microprocessor, and we will try to make some interactive programs, right? So this is the plan for today. We will be making programs by using this xlat instruction for making the lookup tables. Then we will see some interfacing of the input output devices. Then we will see some macro string input output, then interrupt, and then there is a small calculator program which we will also see, right? So to begin with, let us take a very simple example in which we try to interface, a device to our microprocessor, right? So in the morning session, we tried to interface memory to our microprocessor, right? And now I am also telling you the theory for interfacing input-output device to a microprocessor, and then we will try to deal with it, right? So this is an example where we are trying to interface an input-output device to microprocessor in input-output mapped mode. So there are obviously two modes of interfacing the devices to microprocessor. One is memory mapped input output interfacing, and second is input output mapped input output interfacing. And we have seen the theory for that in 8085. So the difference between these two modes will be, in memory mapped input output interfacing, you will be connecting an input output device to the actual address lines, of the microprocessor. And these address lines, they are usually connected to your memory, external memory. So if you are using full 1 megabyte of memory, then you will not be able to connect any input output device in memory mapped mode. But if you are using some less memory, as we saw in today's lecture, some of the address space will be left. And in that space, you can just simply attach your input output devices. But assuming that you are using full 1 megabyte memory with your microprocessor, how will you connect your input output devices? So there is another way. And that way is input output mapped input output interfacing, right? So in this example, we are interfacing an input port at an address of 0740 in hexadecimal. Now, why is the address only of 16 bits or 4 hexadecimal digits, and why is it actual physical address, or is it not the physical address but the offset address? Can somebody tell this? This 0740 is the address where I am saying I want to attach my input output device. So there are few questions that I am asking about that. The first question is, we are using input output mapped input output interfacing. So my first question is this address an absolute address or a relative address? I mean offset address. Anyone with any answers?
Base address.
Base address. Base address of what? Raise your hands if you are present. Okay, approximately 30 out of 50. So, okay, so for all those who are present, please look at this slide and note that we are using input output mapped input output interfacing. So the address that I have written here is the correct address where I want to attach my input output device. I am trying to attach an input port there, right? So the first question that I am asking is it the base address or the actual address of the input output device? Base address or the offset address? Okay, this Kapoor, Ayush, are you there? Ayush Kapoor? Anyone with an answer? Okay, Ayush Kapoor, he's typing something. Okay, his mic is not working. So Ayush, you are using your desktop, na? Okay, so understand it in this way. This address that you see here, all of you please pay attention. This address that you see here, 0740H, how does it come from? Where does it come from? What it means for an input-output device which is to be interfaced. So please keep in mind, if you are not dealing with the externally interfaced memory, the meaning of base address and offset address will not be there. Why? Because this externally interfaced memory, it had 2 raised to the power of 20 locations. So in that case, the address could be accommodated in 5 hexadecimal digits, out of which we assumed that we will only be using 4 hexadecimal digits because the internal registers of 8086 microprocessor can only contain 4 hexadecimal digits, right? So therefore the terminology of base address and this everything else came down, right? However, if you are not dealing with the externally interfaced memory, you are dealing with the input-output mapped input-output interfacing. In that case, uh, what is the maximum number of devices that can be connected in this mode? Maximum number of I/O devices. This so you can answer. What is the maximum number of devices that you can connect in I/O mapped I/O mode? Manaswini, you have raised your hand. Do you want to answer? I'm asking a question. Please answer. Anybody can answer that question. What is the maximum number of devices that can be connected in I/O mapped I/O mode?
Sir, is it 65535?
2 raised to the power of how much?
16. 64.
16 or 64?
64.
64. Where does this number 64 come from? Okay, so do you remember? Do you all
No, sir,
remember?
16. 16, sir, 16.
Why 16? Why not 20? Because address lines are 20 in 8086.
Sir, because a
Because
16-bit address रहता है, because there is 16-bit address.
ये क्या लॉजिक हुआ कि 16 बिट एड्रेस रहता है? एड्रेस लाइंस आपके पास 20 हैं. सो मेरा क्वेश्चन ये है कि जो एक्सटर्नल इनपुट आउटपुट डिवाइसेस आप कनेक्ट करना चाहते हैं, हाउ मेनी सच डिवाइसेस कैन बी connected in IO mapped IO mode? How is it determined, first of all? Is it not determined by the size of data bus? We have read it in 8085. 8085 had external memory of 64 KB locations, right? It had a data bus. The size of that data bus was what was the size of data bus in 8085?
8-bit.
8-bit. And did we discuss that this data bus determines the size, the total number of input-output devices connected in input-output mapped input-output mode? Did we discuss this in 8085? If an input-output device is to be connected to the microprocessor and we are not going to use the address lines which are connected to memory, right? So we will be connecting it in the input-output mapped input-output mode. So we will be using this data bus for connecting it. And the size of data bus for 8085 happens to be 8-bit, and for 8086 microprocessor it happens to be 16 bits. So 2 raised to the power of 16 total devices can be connected in input-output mapped input-output mode for 8086. So you should keep this in mind, right? If you are using a 8086 microprocessor and you want to connect input-output devices in memory mapped mode, then in that case, how many total lines will be available, 1 mega devices can be connected theoretically. 1 mega, because that is the size of externally interfaced address locations for memory that you have. But if you want to connect in input-output mapped input-output mode, in that case, you will use the data bus, right? And data bus, it is only of 16 bits. So the size of data bus is 16 bits, and that is why you will be using 2 raised to the power of 16 input-output devices in this mode, right? So this point should be noted. However, for providing the address, you will be using address lines, only 16 bits of that will be used. But the size of your data bus will determine how many total number of how many total number of input-output devices will be connected in this mode, right? So in this program, this address that I have written here, 0740 in hexadecimal, it is actually an absolute address. It is not base address, not the offset address. It is the actual physical address of an input-output device which is connected in IO mapped IO mode. Is it understood by everyone?
Yes, sir.
Yes, sir.
So let us see this diagram. This is your 8086 microprocessor, and here is your device that you want to connect. This is an input switch, right? So whichever switch is closed, corresponding to that, 1 will be given, and whichever is opened, corresponding to that, a 0 will be given, and that 8-bit data will be stored here, right? And that 8-bit data can be read from this data bus D0 to D7, and it can be brought inside the microprocessor by using specific commands, which we are going to see. Now, how do you select or deselect this device? I mean, sometimes you would like to deal with the input-output device, and sometimes you would not like to deal with it. So how do you do the selection logic? The selection logic is simply this. You have assigned this address 0740H to your input device, right? So whenever you want to deal with this device, you have to activate this buffer. You have to activate this buffer IC by supplying this particular address. And the address, it will be supplied on address lines A0 to A15. This A0 to A15 lines of the microprocessor will be connected here, because those lines only corresponds to the data bus. Is it or is it not in microprocessor?
Yes, sir.
Right? So here you can see that A0 to A15 lines are connected. And how have they been connected? So what is the least significant hexadecimal digit? It is 0. So A0, A1, A2 and A3, you can see that all of them have a bubble before that. So that means if you apply this particular address, all of them will be 0 here, right? If you see this if you see this second hexadecimal digit, which will correspond to this A4, A5, A6 and 7. What is the equivalent of 4 in binary? It is 100. So starting from the MSB. So if you see these 4 combinations, 4, 5, 6, 7. 7 happens to be the MSB, and you have got this combination 0, 1, 00. So that way it is there. And you can verify that this combination will work for 0 and 7, right? So these things are applied here, and this is a NAND gate. That is why this inputs that are applied, they are here with a NOT gate. And after that, after taking these signals, after this address will be available on these NAND gates, and this input-output read signal will be there. And after NANDing them, you will be getting this chip select signal. Is it clear to everyone how this chip is activated? Is this thing clear to everyone? So if you have assigned an address, a port address of 0740 to an input device, you have to have additional hardware to connect that device. So you have to have this pair of NAND gates, and that will be able to generate the chip select signal. So whenever an address bus will have this data, it will be put onto this, and this input output read signal will be activated from the control input of this microprocessor, and that will activate this chip. So whatever is the status of this particular input device, whatever number of switches are closed or opened, depending upon that, the data which is kept in this buffer, it will be read into that microprocessor through this data bus. So this is how an input-output device is connected in I/O mode. Is it understood? Is this hardware example understood? Yes or no?
Yes, sir.
So
So like
yeah,
this
any
hardware
problem?
is so this hardware is like made and it is given the port number like you use this port number for input output.
Yeah.
Is it
Yeah,
okay?
you have a microprocessor and you want to connect some USB hub or you want to connect some keyboard, whatever you want to connect, you tell that, okay, this is your port number, you are connecting this port number here. For example, if you even look at your USB structure in your Windows operating system, there are some COM ports, COM ports, right? So they have got their own addresses. If you connect USB from one port to other port, the address will be changed and the transfer will be interrupted in older version of Windows, right? So whenever you try to connect the input output device, you connect it in two ways. Either you can connect it in the same area where the memory is connected. So if you are using some less memory than 1 MB, then you can connect it there, and then there is no need of assigning separate addresses. The addresses at which it is connected in the memory location will be used. But if that mode is not used, if pure input output mapped input output interfacing is being used, then you need to give some additional addresses, and those additional addresses will be of 16 bits because the size of data bus is 16 bits. And once those addresses have been given, you need to have this additional hardware to activate that particular IO device. Is it understood?
Yes, sir.
After making these hardware connections, from a programmer's perspective, what you have to do, let us see. So the assembly language program, which will be made to take some data, because this is the input device, so this will be giving some data to the microprocessor. So if you want to take some data after making these hardware connections from this input output device to the microprocessor, in that case you have to write these simple lines of code. The syntax is move dx 0740. So dx register is mandatory here. Dx register will contain the port address. After the port address has been supplied into dx, you will use this in command. In and out command, they are used with input output mapped input output interfacing. However, with memory mapped input output interfacing, you will be using regular move commands. This is what we have discussed in 8085 also. Is it or is it not? Yes or no?
Yes, sir.
So that's what we are doing here. We are using in command. That means we are working in the input output mapped input output interfacing. So we have kept the port address 0740 and dx register, and we have used in command in al comma dx. Now you will notice that dx is of 16 bit and al is of 8 bits, but this in command is not transferring any data from dx to al. It is transferring the data from the address 0740, which is kept in dx. So you can see that at 0740 this device has been connected and this is giving a 8-bit data. So that 8-bit data will be transferred to AL register, and after that your system will be halted. So is this program also understood together with the hardware connections? Yes or no?
Yes, sir.
Okay. So now let us see a working example of this in EMU 8086. We will try to interface a thermometer or a temperature sensor in general. We will try to assign a temperature sensor. We will try to attach a temperature sensor to 8086 microprocessor, and we will try to control things. So that will be an interesting program, right? So let me just put on my simulator. All of you can also do that. And in this examples section, if you will browse for more examples, somewhere you will see this file for temperature or thermometer. Yeah, thermometer.asm. If you open this and let us first run this, what this gives us as an output, then I will explain to you the program. So if I run this, you see what happens. Let me put this burner as on. So this burner is on, the temperature of the room is increasing, right? Now I am not doing anything. see, so this temperature has increased, right? And now what I want to do is, if I put this uh, control as off, then what will happen is this temperature will start to fall. This temperature will start to fall. So let us see the complete thing, and then we will try to understand it. Now, what do you see here? Is there any change in the complete system? I have not touched the system. Is the burner off or on?
Off.
The burner has
Off.
become off automatically, right? Now let us see what happens. I will explain everything to you, but first see what this program is doing. Now it has stopped. So why has it stopped?
Because air temperature is 0.
Because air temperature is 0, right? Now let me put on this burner. Okay, air temperature is 0. If you put on this burner, it will again go on increasing. Yeah. So I will explain to you what is happening in this program, but before that, let's note some important point about that, right? So at port number 125, what do you see? The temperature, which is the complete resultant temperature, which is a summation of air temperature as well as the temperature because of this burner. So that temperature in 120 degrees centigrade is shown to you here, and its binary version is shown here. And it is so there is a device which is an output device which is attached at port number 125 in decimal. Is this point understood?
Yes, sir.
And similarly, you can see that there is this input device. There is this input device where you can just on or off this switch. If you on this switch, if you off this switch, this will be all zeros. If you on this switch, this will be 0001. So these are the only two states this switch can have, right? So at port number 127, you have attached the input device from where you will be taking an input, and your burner will be made either on or off depending upon that. Is it also understood? So this control port 127 is also there. Is it understood? Yes or no?
Yes, sir.
Yes, sir.
So now let me read the program for you, and then we will come back to this again. So now, this is a short program for EMU 8086, shows how to keep constant temperature, right? Using the heater and thermometer between 60 to 80 degree. So if you will run this program, the temperature will be kept as between 60 to 80, and accordingly the burner will either switch on or switch off. If the temperature will go out of this range, the temperature will switch on or switch off. it is assumed that the air temperature is lower 60, right? It is assumed that the air temperature is lower than 60 degrees. So there, if we had kept it 0, we could also change it, right? Then this thermometer.exe is started automatically. So this is the problem of the software, not problem. This is the work of the software, and it is also accessible from virtual devices menu of the emulator. So this is just for our information. So if you want to start the thermometer, the assembler directive that you have to write is this: hash start is equal to thermometer.exe hash. So this is since we do not have an actual thermometer which we can connect to our hardware, so they have implemented a software version of this thermometer. And if you want to use it, you have to write this directive to start that software version, right? And after that, you have to write this command hash make bin, and that will put our thermometer in place, and the name of that will be thermo. The name of that will be thermo, right? So these 3 lines are to be written if you want to start the software version of the thermometer. Now let us see the program.
Thermometer.exe is a program.
Yeah, thermometer.exe is a executable file. It's a program, and these 3 assembler directives must be written to activate it. Is it okay now?
Yes.
So now after that, the program is very simple. If you will just have a look at it, you will be able to understand it. So I give you 5 minutes to understand this program, and then you tell me what have you understood. If there is some gap, I will fill it in. There is 3:31. I will talk to you at 3:36. Understand this program. What is this program doing? And then tell me what is the meaning of this. Meanwhile, also, if you are done, you can tell me. So side by side, I will also run the program so that you can correlate it with what's happening. So I'm not touching the setup now. Whatever is happening automatically. It is trying to keep the temperature between 60 and 80. You can see in the thermometer system. If the temperature goes beyond 80, it will switch off the burner. If the temperature goes below 60, it will switch on the burner. See, the burner has been switched on. Now the temperature quickly goes above 80, so the burner has been switched off. So can somebody explain the program to me now?
Yes, sir.
Yeah, please. What's your name?
So Prajwal.
Prajwal. Yeah, Prajwal, please explain the program to me.
Sir, it's like an infinite loop. Uh, it's uh, it's looping from start. Basically, it's taking the input from like the data port 125, like it's written 65, 64, 63 degree that.
Mm.
that we are comparing with 60 and 80. We're seeing that it should be greater than 60 and less than 80. So first we are comparing with 60 and we are seeing if it is if we using jump, if it is lower than 60, like jump JL low,
Yeah.
like if it is if it is hello,
Yeah, your voice is audible.
yeah, it is lower than 60, then you will jump to the low tag that is down. In that what we're doing, like there are for the control put 127, there's on off switch, the 0 and 1. If it is lower than 60, so we need to heat it, so we're putting 1 so that burner gets on, and we're using out 127L to that. And if it is CMPL 80, that is if it is greater than 80, if it is greater than 80, we're jumping to high and we're switching off the burner. And if it will be the burner will be switched on if it is getting to 80, because there's no other way. And if it is not greater than 80, so we'll jump to the last OK tag, and from there we're going into the endless loop.
Okay, that's nice. Has everybody understood the program? Yes or no?
Yes, sir.
So this is a fairly simple program, right? Now what you need to do in the next 10 minutes is, in this program they have given only one range. The temperature should lie between 60 to 80 only. I want a program where the range could be either 60 to 80, or let us say minus 20 to 20. No, not going to the negative direction. Let's say plus 20 to 20, right? So I want this system to work such that the temperature should always be in the range of either 20 to 40 or 60 to 80, right? So if you know this burner is switched on and you are in the range between 20 to 40, then you should go to the nearest possible safe range, right? I mean, one range is 60 to 80, which is already there. You also need to design another range 20 to 40. But if you are in between, I mean, suppose you are at a temperature of 55, then 55 is nearer to 60 to 80 range, so it should go to 60 to 80. Otherwise, you should go to 40 to 20. So will you be able to make such a program? All of you, will you be
Sir?
able to make a program like that?
Sir?
Yeah, tell me.
If we can compare like one thing to another, is there any way like we can use and statement to compare two things?
No, there is no and statement here. For that, you have to write two separate compare statements. Here in this original program, there are two compare statements. Now you have to write four compare statements for finding out a range. And that is why I have given you this program. That is why I have given you this program, so that you will be able to do comparison for multiple things. So think about it. It's very simple. All program is already available with you. You can go to this examples section and open thermometer.asm. You will find the same program. There only you have to make these changes. Now the safe range will be 60 to 80 or 20 to 40. Your temperature should always lie between this. But if it is not in this range, it should go to the nearest safest range possible. Is the problem understood by everyone? Is the problem understood by everyone? Please raise your hands if you have understood the problem. Okay, so if the problem is understood, all of you please try to implement it. It is 3:40 by my watch. I will talk to you at 3:50, and then you will explain whatever programs you have prepared, right? Remember that the port numbers 127 and 125 are fixed for thermometer and this in this software only, not in the real world, but for in this software they have assumed that a thermometer will be permanently attached to port number 127, and for 125 there will be a on off switch, right? So that is fixed for that. So you can't change that. But keeping that in mind, you should be able to now implement the program that I have given to you. And you are now aware of how to connect, how to make connections in hardware. And after making connection, how to use in and out statements to be able to control that device. So from this stage, your way of controlling the external world of microprocessor also begins. So please make this first program. We will talk at 3:50 again. In the meantime, I am available. If you have any questions, you can always ask. And if you really make the program, you can verify it for yourself whether it is correct or not by checking the demonstration by just running that program. And after making the program, if you do not want to reveal it to your friends, you can always send it to me on WhatsApp. So your identity will be safe, because otherwise your friends will ask that, oh, you are reading. This happens in engineering colleges. So, okay, then we will talk at 3:50. If you have any doubts, you are welcome to ask. Okay, so anyone who is done with the program and wants to share? Priyanshu Garg. You want to share your program? No. Okay, raise your hands if you all are present. So let me see how many of you are present. Okay, approximately half of the population is sleeping. Okay, so anyone who wants to share their screen for the program that I have asked for? No problem. You make that program, and when you will be asked to submit, you have to submit that. Meanwhile, let's have a look at this second program, right? So, this second program, you can find it in this examples and this LED display test. LED display test is there, and you can just find it there. So, I have already opened this program, and this program is an important program for us. Why? Because up till now, our 8086 computer didn't had any monitor, right? We now want to interface a monitor to it. So at that time, what could be one of the possible monitors? You could have a series of 7-segment displays. All of you are aware of 7-segment displays or not? All of you have seen a 7-segment display?
Yes, sir.
Yes or no? Not seen?
Yes, yes.
You have seen a 7-segment display. So in this program, you will see that if you emulate it, this collection of 7-segment displays, 5 7-segment displays are here. And by using this, we are going to make some program, right? So I will just remove all the lines of this code and we will simply see this. Uh, 1, 2, 3, 4. Let's say we want to display this. I am not putting H after that, and let me emulate this. So what is displayed here? 4460. So by default, it will be taking everything in hexadecimal only, whether you put H or not. So here you notice that I have simply moved in AX 1234H. There is some value which I have moved to this AX register, and out 199 AX. So this 199 is the address for your display that is being connected, and whatever is kept in AX, it will be outputted to this 199, right? So this is how you can display something onto a screen, but the hexadecimal equivalent will be treated in these numbers and its corresponding decimal equivalent will be shown here, right? So if you see the full program, this is the full program where they have just write these first two lines for explanation how to display the numbers in positive and negative format. So the main part is this complete loop where they are trying to just run this program and display numbers from 0 to whatever maximum number is possible in the form of a counter. So you can emulate this program and see it for yourself. Let me run this for the entire duration. So this is what has been displayed. And since this port is a 2 bytes display, so it will keep on displaying till the numbers which are possible in 2 bytes. And what is the maximum number that is possible in 2 bytes? Obviously 2 raised to the power of 16. So till that numbers will be displayed here, right? So is this simple program understood by everyone? So is this simple
Yes,
program
sir.
understood by everyone? Yes or no?
Yes, sir.
Okay. So now let me give you a program to implement. You have already known what
Sir,
macros are. Yeah, tell me.
what is this minus 5678?
Okay, let us remove this. That is of no use. That was for the purposes of explanation. So this much program is sufficient. I will tell you what it is. If you even run this program, this will run perfectly. From 0 to some maximum number it will go, and again it will come back to the same thing. Now the earlier program, the default program that is written in this is this, right? And what is this program? This program, I mean the author first of all wants to tell you how to write a 2 byte data into the AX register and then how to output it to port number 199. So this is what he wants to explain to you. In the second line, he wants to explain you can even put a negative number. Its hexadecimal representation in 2's complemented form will be shown at the display. So if you have some negative number, that negative number can also be displayed, and you will be seeing a hexadecimal representation for that in 2's complement form. So through those two lines, the author wants to explain that. But here, if you will run these two lines, they will hardly be visible to you because there is this infinite loop and it will start to run. So all of this will be overridden whenever you will start to execute this program, right? So if you start to execute this program, you'll see that the display will continuously jump from 0 to some higher numbers and so on. So the first two instances will be lost. Right, so is the purpose understood for those two lines?
Yes, sir.
Right. So that's what is happening here, and things are getting displayed. Now, you all are aware of macros, right? In one laboratory, we made programs for macros. Is it or is it not? We have made a program for macros.
Yes, sir.
So, can you just write a macro in this same program? Can you just write a macro by understanding this program in which whatever is the content of your uh, flag register, let us say whatever is the content of your flag register will be displayed onto the screen that we have connected to it. Will you be able to write a macro for that? Whenever that macro is called, a macro is not called, a function is called usually. So whenever that macro is used, the content of flag registers will be displayed onto the LED that we are using. Will you be able to write one such program? You have to use various things for that. First of all, you have to see the basic program for macro, which is already available to you. I will show you the basic program for macro that is available. So these are the basic code folders which I have given to you. If you want to revise how a macro looks like, so we have a program for macro somewhere. So this is defining a macro. This is the program for that. So here you can define your macro, right? Now, from here you can learn what is a macro. After that, what you have to do is, you already are aware of this program, how to connect a LED and how to display numbers onto that. Now you need to see a method by which you can copy your flag register somewhere. So you have this command push F. We have read the command push F in the second last lecture. Yes or no? Yes or no?
Yes.
So that pushf command can be used to push the contents of the flag register onto the stack, and from that stack you can copy it into AX register as shown here, and then display it whenever that macro is called. So these three things are to be combined. Will you be able to do it? Yes or no?
Yes, sir.
So please try doing it, and I give you 20 minutes for that. It is 4 o'clock, and at 4:20 we will talk. This is a fairly big program, but understand this fact that from this point you will be able to control the external world through this microprocessor. So this program that you are making, it is making use of very simple things, macro, and this understanding of how to display something onto code, but you will be able to change things your way. Later on, we will make programs for stepper motor, etc., for traffic light control. All of the devices are available here. But for that, you should begin from somewhere. So this is the beginning. Take 20 minutes and try to implement that program. And if you are done already, please message me on WhatsApp, and I will be there to see that program. Right? Is the problem understood by everyone? If it is understood, please raise your hands. How many of you have understood the problem? Poojan and Dinesh, your hands are already up. Please raise your hands if you have understood the problem. Understand, this is a very important program. You are trying to control something from the microprocessor for the first time. So please try to make it by your own. If you are able to make it, that's okay. If you are not able to make it, you will be able to make it once I will explain it to you. But now this is important. You should be able to control this world by using this microprocessor, right? So for stepper motor, for this thermometer that we have seen, definitely we will be able to make program. But in real world, you will be controlling real devices. When you will come to the actual microprocessor laboratory, we will have an actual temperature sensor, we will have an actual stepper motor, and by connecting it to the microprocessor, you will be able to manipulate its speed. Right? So that's what we need to do by uh, this microprocessor. Okay,
So
so I will
is it
leave
like
you.
after
Yeah.
so after the incrementing we're displaying the number. After that you have to use the macro to display the flags.
No, no, no. The
And
program is very simple. You can write a program of your choice. Suppose you are adding two numbers or subtracting two numbers, and because of that operation, your flag register bits will change. Obviously, is it or is it not?
yes, sir.
So after few lines of codes have been executed, and if you want to see what is the content of flag register, that flag register should be displayed onto that particular display that you have connected. That's what I want. So you can choose a program of your choice that, okay, I am making a program for addition, and after addition, definitely carry flag will change if the numbers are too big, and I want to see the status of the flag registers onto my screen. So that kind of thing. Understood?
Yes, sir.
Okay, so please make it. I'll talk to you at 4:20. Meanwhile, if you have any doubts, please WhatsApp it to me. Okay, so please raise your hands if you're already there. Yeah, so the thing is that one of your classmates has already implemented this program in less than 10 minutes, Karthik Pant. So, Karthik, you can share your screen and explain your program. I have made you presenter.
Okay, sir. Yeah. Sir, is it visible?
Yeah, it is visible.
Okay. Yes. One. Hmm. Yes, sir. So here I have written the macro. I called it display. So it first I use push-up functions to push that flag content and then pop it into X, then output it in 199 address. So that is for the LED. So here is the starting of the program. So first what I do is set LED display to 00 with this, and then I perform addition of two numbers. So here it is A in the starting. So I guess that would, nahi, okay, that won't. Like this addition function would cause some flag registers to change their value. So then I call display macro, and then it displayed the values on LED and on this.
Okay, so please just show whether the flag content is displayed correctly or not onto the LED. Have you done the calculations for decimal to hexadecimal conversion, which will be displayed onto the screen for flag register?
No, sir.
So please run your program. Let us see what is displayed on the screen.
Yes, sir. I will run this.
Hmm.
So it shows 642.
642. Okay. Please note the contents of your flag bits. You can check the contents of your flag bits at the bottom. I mean, there is a flag thing. So you can note all the values of flag bits from there. And there are some don't care bits. We do not know whether their value will be 1 or not. But please try to match the value of sensible bits with the binary equivalent of 642, which was displayed on screen. So if it is correct or not. If this is correct, then that is correctly displayed, and I am sure it will be.
Okay, sir.
Please match
Oh.
it and then show the results to me.
So, sir, can I like stop sharing and then do that?
Yeah, you can do that. You can just stop sharing your desktop and do that.
Yes.
So is the program understood by everyone else?
Yes, sir.
Okay, so it's a fairly simple program.
Yes,
So
sir.
you see this, only 5 or 6 lines of codes have to be written to control the external world through this microprocessor. We have done longer programs, right? When we were dealing with the internal memory, we were using the stack, we were doing this and that. So we did a thorough exercise of writing programs, right? But when it comes to controlling the external devices of the world, from that huge knowledge that you have acquired in this course, only small portion is used. And this is a typical example that we have just seen. And this kind of questions will be there in your examination. So the questions will be like this. Assume that there is a LED display. It will be able to display 2 bytes of data in decimal. Assume that it is attached to port number 127. Draw a hardware circuit for attaching that LED as an output device to 8086 microprocessor. After that, write a program to display the contents of flag register through a macro whenever it is needed. So this kind of program will be there in your midterm examinations. Will it be easy enough for you to do? And there will be step marking. If you are able to do the hardware part correctly, 50% of marks. If you are able to do the complete program correctly with hardware, then 100% marks. So that kind of problems will be there. Hardware plus software problems will be there in your midterm examinations. So will it be okay for all of you? put down your hands, please. There are 4 or 5 people who have their hands raised. Okay, anyone else who has made this program in some different way? Okay, let's now discuss something else. Raise your hands how many of you are present. So let me see how many of you are still active. Then I will tell you another concept. Let me see how many of you are still present. So out of 62, only 30 people approximately are present. Okay, so let's now see something else. In the code folder that I have given to you, there is this program of calculator. There is this program of calculator which I am going to demonstrate, and we will learn several things from that, right? So let me just put on my simulator.
Sir,
Yeah, tell me.
you have told me that your output is wrong. Can you explain?
Yeah, because the program that you have sent me over WhatsApp, wait a minute, I will see your WhatsApp again. Yeah, you have written in the display macro push F, and after that pop EX out 19. Okay, sorry, I haven't seen that those two lines before end M. I thought that after push F you have ended those lines. I mean ended that macro. So that is correct. That's not wrong. It is correct. So have you verified the numbers that are appearing on the flag bits and the decimal equivalent of that?
Yes, sir.
It is coming out to be correct, right?
Yes, sir.
And from your program you can
It
remove
was
line numbers. Yeah, from your program you can remove line numbers 30 to 34. They are of no use.
yes, sir.
Right, so that can be removed. Otherwise the program is perfect. I haven't seen that you have ended the macro after writing those two lines. So probably because of the indentation that you have applied for push F. Right. Okay, so now let me discuss another simple program, very simple program where I have designed a calculator, right, by using various macros. So through this program, we will learn several things: how to display the string onto the screen, how to take input from the screen, etc. Right. So this is how we define a macro, and let's see this first macro. This first macro is simple print macro, and we have seen it in one of the lectures only, that if you want to display something onto the screen, then you can use this print macro, and this print macro will be able to display strings onto the screen, right? Our microprocessor that we are using, the screen that it is using, the screen that this microprocessor will use was LED, right? The LED that we have just seen. Otherwise, they have also given us an option to interface our microprocessor with the screen of DOS, disk operating system. So if you want to display some string onto that DOS screen, this macro will be used. And we have already discussed this macro in some lectures. Yes or no? This print macro was already discussed in some lecture.
No, sir.
Yes, it was discussed or not?
No, sir.
In one of the lectures where, I had bad internet connection and I told you to read that particular video from the already provided videos. So in that macro was there. Have you not seen that? Raise your hands if you have seen that video on that day when my internet connection was poor and I gave you a pre-recorded video to see for one class only. So how many of you have seen that? Please raise your hands. Manaswini, Dinesh, Prajwal. Only 3 people? 5. Okay, so those who are not aware of macros, they have to read that. That day my electricity or I think connection was not working, so I gave you that one pre-recorded video. But anyway, I will explain it again here for the people who want this explanation again. So see, if you want to write some lines in your code again and again, there are many different options that you can have. You can design a function and that function can be called, right? But calling a function is an expensive matter because you have to put things onto the stack, you have to put the return address onto the stack, and then whatever is the content of current registers, it will be changed when you jump to the function. And when you return back, the original state of registers cannot be retained if you do not put them onto the stack, right? So instead of using those functions, you have an option of defining macros. Macros means full forms. Macro means full form, right? So in short, you will be using this keyword called as print. This is not a keyword, this is a macro. So you will be using this macro print, and wherever you will write print in your program, these lines will be automatically inserted, right? So if you see your main program, here, let us see our main program. Yeah, this is our main program, and here you have written this print statement. Okay, let me just go to the main program. This is not, yeah, this is your main program. And here you see that I have used print str1, print str2. So in place of this print str1, this complete code will be inserted. This print macro will be inserted with the argument as str1. And accordingly, the things that are described by this macro will happen. So a macro like a function is not called because it is just a full form of what you have written. So when this code will be assembled, now this print line that I have written here, it will not be treated as a separate function. Rather, in place of this print, all of these 5 or 7 lines written here will be inserted and then your code will be run, right? So that's what we mean by macro, and there is some difference between a function and a macro, right? So what do you do in function? What do you do in the macro? You have an argument which you can pass, and accordingly you can do anything with it, and you can end the macro. So to be able to display something onto the screen, for example, I have this string number 1. So in the data segment, since I am using this org100 style of coding, so I am using .com mode of programming, and in the data segment, I have begun it with .data, and I have defined string variable. str1 is the name, defined bytes, so every location will be of 1 byte, and this is the complete string that I have defined. And strings have to be terminated by a $sign. This is a mandatory thing in this 8086 programming, right? So this is where I have defined a string, and this is stored in my data segment. I want to display it. So for the purposes of display, we have already discussed that you have to first of all move the offset. You have to first of all move the offset of the argument, that is str1, which you have passed to it, into the dx register, right? Then after, you have to move a value of 09h in the ah register to be able to display that string, and interrupt 21h is to be called. So offset of that string, that is the name of that string, has to be moved into dx register. Name will have corresponding address, so that address will be moved onto dx register, and this ah will contain 09h. Then only if interrupt 21h is called, then your content will be displayed onto the screen. And the rest things that you see here, this is for carriage return character and new line character. After printing the line, you want to put the cursor onto the next line. So Carriage return character means enter will be hit after that by using these 3 lines. If you move a value of 0D in DL and 02 in AH and call interrupt 21H, then your carriage return character will be automatically typed. That is, enter will be typed. And after that, if you want to go to the new line, these values have to be used. DL will have 0A, AH will have 02, and interrupt 21H will be called. So a combination of values in DL or DX and AH register will decide what will this interrupt 21H do. So interrupt 21H is performing 3 different functions here. First, it will print the string. Second, it will print the carriage return character, and third, it will go to the new line by seeing the various combinations in AH and DX register, right? So that way you have defined your macro, and it will be used for printing the string. And the second macro that we have defined here is for taking the input from the user from the screen. So here you will see that carriage return character and the new line part will remain the same. The only different point will be that AH will contain a value of 01H here, and when interrupt 21H is called, the screen will ask you to enter something. The screen will ask you to enter something. So whatever you will enter, it will be taken up there, right? So this is where you can take inputs from the user, right? Then you have defined a result macro. Result macro, okay, this is for some kind of result. So I don't know what it is. We will talk about. Okay, so you have to display the result in decimals. So for that, this result macro is defined. I will discuss this later. But let us see the program first. In the main program, you have initialized the data segment. Now you are calling this print str1. So this print str1. What is your string 1? Welcome to the simple calculator program. This will be printed onto screen. Then str2, str3 and str5 and str4 will be printed in that order. str2 is you will be able to perform operations of addition, subtraction, multiplication and division only through this calculator. So this will be printed onto the screen. Then string number 3, that is this, choose an operation. So you have to choose an operation. This will be printed. Then string number 5. String number 5 is this dollar sign will be printed after you enter, this dollar sign will be printed onto the screen. Then after that, you have this string number 4. String number 4 is choose an operation. So this will be printed after the dollar sign, right? So let us run this program and see if this actually happens or not. So I have run this program, and you can see that on the screen these lines have been printed. Welcome to the simple calculator program. You will be able to perform operations of addition, multiplication, subtraction, etc. Also, you can only use single digit natural numbers for performing the calculation. So choose an operation. Enter 1 for addition, 2 for subtraction, 3 for multiplication and 4 for division. Right? So let us choose addition. So I have entered 1. So it is asking that addition operation is there. So whatever is the number 1 you have to enter for addition. So suppose I want to add 5 with, let us say, 2. So the result is 7 and the emulator is halted. So you can see the screen, the result is 07. So is this program understood?
Yes, sir.
So here, you can see the usage of macro as well as how to take inputs from the user. How to take input from the user is also very clear here. Now, your task is to take the input from the user. User will be entering some number and you have to display it onto the LED screen that you have already used. Will you be able to do this very small program? Take the input from the user by using this macro. Define a macro for taking input and take the input from the user. After taking the input from the user, whatever is the input, you just display it onto the screen. LED screen, not onto the DOS screen. So there will be 2 screens in your program. One will be the DOS screen where the user will give input, and second will be the LED screen where you will display the same number. So will you be able to do that? Yes or no?
Yes, sir.
Okay, so please try that program in the remaining time. It is already 4:30, so I will talk to you in 10 minutes, right? Try that program and tell me whether you have been able to do it or not. So in this program, the point to learn will be that you have learned how to take input from the user, and that input can be passed to a peripheral, right, by the microprocessor. So here microprocessor is just taking the data and supplying it to the peripheral. Now in the consequent programs, we can increase the complexity by saying that, okay, take the number from the user as input on the DOS screen, then multiply that number with say 2 and then display it onto the screen. So microprocessor will be doing some processing in that case. So this is a pilot program of the general scenario that you encounter in real world. You take the data from the user, microprocessor will process it, and then you will get the output through some peripheral. So this is how things happen in the real world. So if you are able to implement this much, then you will be able to handle any situation in terms of hardware as well as software, right? So please try that program, and I will see you at 4:40. It is 4:31 by my watch. Meanwhile, if you have some doubts, you can always ask. Is the problem understood by everyone? Please raise your hands. Okay, I see few hands, only 10 hands being raised. Rest of the people, what are you doing? If you haven't understood the problem, why are you not asking that what is the problem? See, the paper of midterm will be fairly involved. There will be no time for doing cheating. Like in the mini examinations, you knew that I have methods to evaluate people properly. So in midterm exams, do not think that you will just pass this subject by copying the answers from everyone. That will not help. Because even if you will copy, there is no guarantee that they have written 100% correct answers. As I have told you that the questions will be of this form, hardware as well as software. So, you have to apply your mind to be able to write your answer sheets. Copying will not be an option in this subject. Please remember. I'm very strict about marking and impartial marking. And I know the methods to eliminate possibility of cheating from examinations. So please do whatever I tell you to do here itself. These are simple things, but if you skip them, they will become very complicated because all of this is not written in books at one place. Textbooks will only tell you the methods to do things, but bringing all these things together and interfacing and making programs, this is not told in any book anywhere. So practice it here itself. Okay, so I'll talk to you at 4:40. Till then, if you have any doubts, you can ask. Okay, so Karthik has made the program and he would like to share his screen. Karthik, you can share your screen. I have made you presenter.
Yes, is it visible, sir?
Yes, your screen is visible.
Yes, sir. So here I have taken the input. I actually could not find that macro code that you were showing. So I did
Mm.
like this. So here I did the input thing, and then I used display macro. I passed AL register because there was the value stored. Then here what I did was in AH I stored 00H because earlier it was having 01H, and then I subtracted 30. I actually observed that whenever I typed 5, then in AL it used to store 35. So
Very
that
nice. This is a very nice observation because ASCII codes for 5 are 35. ASCII code for 0 is 30. ASCII code for 1 is 31, and so on and so forth. So subtraction will be necessary. And for that, you could have used the command ASCII adjust for, I mean, there is multiplication. For multiplication, it is there, but for normal things, it is not there. So subtraction with 30 will do. That is true.
okay. So then I did that out thing on port
Out.
190.
So means without using the macro, you took the input, which is fine, and through the macro, you have displayed it onto the screen. So let us see the output of this.
Yes.
Let's enter 2. So let's see your screen, I mean LED. Yeah, 2 is displayed. So this is correct program. Very nice, very good. So everybody else, have you understood the code?
Yes, sir.
So it's a fairly simple program, and he has made it in I think few lines, 7 or 8 lines. He has made the code, and this is the amount of programming you need to do when you interface hardware. So in robotics, etc., you will get you will get various components which will be connected together, assembled together, and to move a robotic arm, you have to write these kind of programs. These small kind of programs. So now you are potentially capable of operating a robotic arm. So explore this hardware which is called as robotic arm. It is interfaced with usually Arduino. Arduino is a computer on chip. It has a microcontroller of itself, and it has several peripherals. So it is a full-fledged computer system of its own to which various things are interfaced like robotic arm. And through that robotic arm you could do multiple things, right, which you cannot do by your own hand. So these kind of procedures are being used in medical surgery for making surgery procedure, free from actual humans. So robot will be doing surgery with a very good precision. If you have to dig a hole in skin, which is of few nanometers, you doctors can't do that by hand because small vibrations in our hand will make that hole very bigger. So if you want to drill a hole of nanometers through a precise instrument, robots will be able to do that. And these small kind of programs are written for actually doing that, right? So in today's class, you have been able to use the microprocessor to control the actual hardware. Unfortunately, because you are not in the laboratory, so I cannot tell you how actual hardware can be connected to the microprocessor system. Although I have told you the procedure, and it's trivial now for you to connect it whenever you will see that. So that can be actually easily connected, and you can see that hardware moving by writing these simple programs, right? So this way you have to write the programs, and this kind of questions can be there in your mid examinations for interfacing your hardware and writing the programs, right? So I think only 15 minutes are remaining, and we have started 15 minutes early. So there is a lot of work that you have to do for today's lab. So I will only put one today's lab in your files folder. You can see that file, and it will be a combination of hardware and software, right? For interfacing that thermometer program, I will just give you some tasks to do, or maybe for LED. So I will phrase one problem. You have to solve that one problem from hardware and software both perspective, and display your results by putting the screenshots, right? So that's what you have to do. So quickly raise your hands if you all are there. You can stop sharing your screen, Karthik. Please raise your hands if you all are still there. Okay, so I see only 32 people raising their hand. 34, 37. Rest everyone is logged in but sleeping or went somewhere. Okay, so I'll quickly take the attendance then. And in the videos it is evident how many number of people are present. So accordingly, the attendance will be compiled. So any doubts in today's lab session? Any doubts, anyone? In today's lab session?
Sir, what was the second program?
The program that we discussed just now?
Yes, sir, last program.
The last program was simple. In that you had to take input from user and display it onto the LED. For taking the input, you have to use DOS screen. You have to use DOS screen, right? User will enter some number between 0 to 9 and that number should be printed onto the screen. I mean the LED screen in that case. So you have taken the input from one interface, which is DOS screen, and you have displayed it to the LED screen. So this is what you have to do, right?
No, sir, you gave second version of this program.
Where you have to add something, etc.
Okay, sir.
No, this was supposed to be
multiply.
I just told you that now the complexity can be increased. I mean, you can take some data from the user and then you can just, try to process that data in the microprocessor and then supply it as an output. So this is what typically a computer system will do. It will take data from you, it will process it, and it will display it on the display unit. Right?
Okay, sir.
So that's what, tell me.
So you were telling the sort of questions like hardware and software. Could you tell that again?
The thing is,
For the
as
exams you was.
Yeah, as you saw in the beginning of lab today, I have told you how to interface a input or output device at a particular port, right?
Yes, sir.
So a question could be there which will tell you to interface a particular input output device, let us say LED display, at a particular port, and after creating the hardware connections in form of diagram, you need to write a program to take either input or output from that particular peripheral.
These devices will be like familiar devices, like which you are covering, or it could be anything.
No, it could be anything. I will show you one example. The example that I had shown you at the beginning of this lab. This was the example. So suppose I could give a question like this. This is a device. This is a device which is having 8 bits of input. If the switches are connected, that means an input of 1 is to be taken, otherwise an input of 0 is to be taken. Now you have to interface this device at address 0740H. You have to interface this device at 0740H. So design an appropriate hardware for that. So you have to design this complete hardware, right? And after designing that hardware, suppose the content that is supplied by this input device is, let us say, 11110000. So take that as an input by writing this program. So you have to write this assembly program for that, right? So this is in the form of a slide, but when you will make this diagram, you have to explain everything that we have selected. These two gates because of so and so reason, and chip select signal is formed because of this and this region. I mean, this IORD signal will be there, and all of the signals will be ANDed, and data bus is taken. Why the data bus is taken? Why the address lines are till A15 only? So this all thing needs to be explained while you will design this hardware circuit. And this program also needs to be explained that in your DX register you will keep the port address of the peripheral that you have connected, and through this input command you have you have taken the data from that port into the AL register. So AL is the register in which the data is taken and the system is started. So those kind of problems will be there, right?
Yes, sir.
So if there is some other device other than this, then the specifications of that will be given. For example, if I will tell you that there is a 7-segment display which is connected, so how to deal with that, that will also be told here, right? So it will be a problem which will require your 100% attention. And I do not expect everybody to solve 100% of that problem. All the marks will be given on step-by-step basis. And the approach that you follow while designing your system, that is, you will be able to use minimum hardware, and your program should also be a small enough program and efficiently implemented. So marks will be given on that basis. And for the
Sir,
people who have followed my lectures, it will not be very hard. Yeah, tell me.
so in this we are ending the lower part of address bus and higher part of address bus, and then we are ending it again. Can we not end it in one gate like A0 to A15 and with IO read?
No, this is not AND gate. If you see, this is NAND gate. NAND gate with some inputs as
Yeah, yeah,
inverted
yeah.
in. So
And
the operation of, like two AND gates, if they are used with two inputs, you can have a bigger AND gate with 4 inputs and 1 output. That is true for AND gates, right? But for NAND gate, it is never true. For NAND gate, it is never true. So when you read your
okay.
digital logic circuit design course, there you must have seen that you can either use a combination of two AND gates with two separate inputs, and then they can be combined by using another AND gate, and there will be a third output. Or alternatively, you can use a bigger AND gate which has got 4 inputs and 1 output. But this cannot be done with XOR gates. If you have two XOR gates with 2 inputs each, then you cannot connect them by connecting a third XOR gate and taking that as an output. So in that case, this is also the case here. This is not a AND gate. This is a NAND gate. And it has been connected through this. So these inverted inputs are there. So this cannot be done. You are saying that all of these signals should be attached onto a single NAND gate, and things can be done. So that will not be possible, because some of the signals are inverted here and some of the signals are not inverted. So NOT gates will be there in between, right?
Yes, I didn't see the bubble. That NAND gate.
So these kind of problems will be there, and for people who have followed my lectures and laboratories with full honesty, they will be able to do it. And remember that, there will be an option of copying your answers from everybody else, but that won't help, because I have methods to minimize cheating. You might have seen that in minor examination. So with my subject, if you know the thing, you will pass the subject. That is how the subject will go. And for people who are doing my lectures seriously, there is nothing to worry. Paper will be extremely simple for you. But for people who believe that they will learn all my videos by sitting for 15 hours and reading 15 videos, things will be very difficult. So please follow things as they are presented to you. And if you find time, do practice small programs by yourself. Today I have told you to interface only LED and maybe a thermometer, etc. But in your EMU 8086, there are ample of examples. There are traffic lights, there are stepper motors, and there are various devices which are connected. So you can play with that complete system. I can't tell you each program in this limited set of time that we get. So you can play with it if you are interested in this subject. And this subject will be very helpful for your placements also, because that way you will be able to apply in companies of core electronics also, because all that we do in electronics is we have already ready-made chips, and we hire programmers to write program for that. We create the hardware. Now you have the capability to create the hardware also for a computer system. So this subject is a very powerful subject, right? Any other doubts? If anyone has any other doubts, you may ask. Okay, so I'll close the session for today. You're saying something, Shivanshu?
No, sir. No, sir.
Okay, then I'm closing the session.